Hello everyone, today I'm going to be teaching mesh analysis and I'm going to be teaching the shortcut method that I actually haven't seen anyone else use on YouTube, and I would say it is the fastest method for solving the mesh equations and getting your currents in the meshes. So let's get started. What is a mesh? What is mesh analysis? Well, mesh analysis is a circuit technique that involves KVL and Ohm's law to calculate the current, around closed loops or in meshes. So if you don't know what a mesh is, I'm going to briefly cover it, and it's pretty easy to understand. Oh, I want to erase this. So a mesh is essentially, it's just a loop that does not contain any other loops. So if you don't know what a loop is, it's just a closed path that doesn't go through a node twice. So for this example on the left, there is 3 meshes. And if you'll notice the example on the right, it's the exact same circuit, but I redrew it so the resistor doesn't go diagonal. And instead, I took this resistor and I said, okay, I can't really adjust it. Well, I took that resistor and said, hey, let me just slide it down like so. And this is the exact same circuit, so I have my I1, I2, and I3. So I also want to go over one other thing. So let's say I had a resistor going through here. Then how many meshes would I have? Well, I'll have 1, 2, 3, 4. And if I had another resistor going in the middle like this, then I would have one more mesh. I would have 5 meshes, and if I had another resistor going through, I'd have 6 meshes. So moving on, so this circuit has how many meshes? Well, obviously 3. So I hope you guys understand what meshes are. It's pretty simple. I don't think I need to make a separate video for what is a mesh, because it's a really basic thing. So I'm going to go over this example right here. So to start off, to do the shortcut technique, you obviously have to label your meshes. That's step 1, and I've already done that here. And step 2 is to obviously write down your givens and unknowns. So I have I1, I'm going to write it like this. I1 equals I2 equals, and I3 equals. We're actually not given any of the mesh currents, so I'm going to write question marks for all of them. So I have 3 unknowns. So I will need 3 mesh equations. And this applies to all circuits. However many unknowns you have is how many equations you'll need. So if I have 5 unknowns, 5 equations, for an example. So our next step is to write the mesh equations. So I'm going to start in order from 1 to 2. 1, 2, and 3. So let's write KVL at I1. And now, similar to the nodal analysis technique, what we have to do is, in our mesh equation, we will make whatever we're looking at for the KVL. So if we're doing KVL at I1, we make that positive. So we make I1 positive. If it was KVL at I2, then I2 would be positive. But since we're looking at I1's KVL, we're going to make that specifically positive. And that is the shortcut technique. And then any neighboring meshes, you don't have to write this part, but I'm doing it to explain. So any neighboring meshes will be negative. So my neighboring meshes are I2 and I3, and those are negative. So negative, those will be negative. And now I'm going to combine Ohm's law and KVL. So I'm going to start from I1 to I2 to make it easier to write into my matrix. So I1 multiplied by all the resistors in the mesh, or the sum of all the resistors in the mesh, which is what's in my mesh. I have I1 here, so I have this resistor and this resistor. So 4 plus 6, and then subtracting I2 and multiplied by any resistors attached to I2 and I1. Well, there isn't. There's a voltage source, but we need resistors. So there isn't, so we write 0. And if you're wondering, why are we just writing the resistors normally? Well, we want voltages, KVL. KVL involves voltages, and we need V is equal to IR, which we have over here as Ohm's law. So we're multiplying currents and resistors, which in turn gives you voltage, because hence I times R. So I1 times 10, which was our total resistance, that gives us voltage. Okay, so moving on, we have minus I2 times 0, and then minus I3 times the resistors connected to I1 and I3. Well, yeah, there's the 6 ohms. They're both touching, or they're both connected. So minus 6 equals any voltages in the mesh. Well, yeah, there is. And what we're going to do is, for KVL, we look at the sign leaving. So my I1 is going this way, and what I'm going to be doing is looking at the sign that is leaving, because that's how KVL works. On the right hand of the equation, I look at the sign that is leaving, and on the left side of the equation, I look on the sign that's entering. So I could just look at the sign that's entering, so plus 6, and then move it to the other side and just write minus 6. But I'm mostly just going to be looking at the sign that's leaving, because it's easier to write. And you could, if you look at my polarities video, you could just like change it up if you want to, but you have to stick with the directions. But what I do is I usually just make the right side the leaving sign and the left side the entering sign. It just makes things easier. Okay, so next is KVL at I2. And my I2 is going to be positive because that's the mesh, or that's the current I'm doing KVL at. That will be positive. And then I'm going to look at my neighboring meshes. You don't really have to write or label even the way I'm doing for my mesh analysis, but I like to when I'm explaining videos to make things easier for you guys. So I1 and then I3, and those are going to be negative. So now I'm going to be looking at all the resistors in that mesh. So 3 and 9 ohms. So I'm going to start off with I1, and I1 is negative, so minus I1, and then multiplied by any resistors connected to I1 and I2? Well, no, there's not. I1 is going this way, I2 is going that way, and there's 0 resistors, so I'm going to write 0. And then plus I2, because that is positive, we're doing the KVL there, plus I2, and multiplied that by the sum of all the resistors, which is 12. And you'll notice that whatever mesh I'm doing the KVL at, that's where I include all the resistors in that mesh. So I'm doing KVL at I2, well, I'm going to include any resistor in that mesh. And then just include the ones that are connected to I1 and I2 for all the others. So I have 9 plus 3, and then minus I3, and I just look at any resistors connected to I2 and I3. They have to both be connected in order for the shortcut technique to work. So I have my 3 ohm resistor that's connected. They're both touching, I would say the same, this resistor is touching both meshes, I2 and I3, so I include it, so 3, and then equals any voltages in my mesh. Well, yeah, I do. I have this 6-volt source, so I2 is going this way, is going clockwise, and I look at the sign leaving, and that's my positive sign, so I write 6. That's my equation 2. Try to do the equation 3 without looking at anything, and then you can play my video. So now KVL at I3, and obviously I3 will be positive, and my neighboring meshes will all be negative. So I1 and I2 are neighboring, I1 and I2 are neighboring, and they're going to be negative, so minus minus. And now I'm going to be writing my equation starting off with I1, so minus I1, and I'm going to try to include this right here, minus I1 multiplied that by the resistors connected to, or the resistors touching I1 and I2, so I1 is over here, and I3 is over here, and they're both touching, so I'm going to be including that, minus 6, and then minus I2, and the resistors touching I1 and I3, sorry, I2 and I3, so I2 and I3, I'm looking at that, and they're both touching this 3 ohm resistor, so I include 3, and then plus I3, and the sum of all the resistors, which is 6 plus 3 plus 12 equals any voltages leaving, any voltages in the loop. Well, no, there isn't, so 0 equals 0 is my third equation. So now what I can do is put these 3 equations into a matrix and solve for my I1 and I2 and I3 and get an answer for my currents in the meshes. So that's what I'm going to be doing, and I'm going to show this step to you guys. You feel free to fast forward if you want to. So I have my 6, 0, and then I have I1, I2, and I3, and for my, I'm going to be starting from the first equation, so 10, 0, minus 6, and then starting from here, 0, 12, minus 3, and minus 6, minus 3, and 9 plus 12 is 21. And now I just have to solve for this matrix for the reduced row application. And I'm just going to be using a matrix calculator, and you'll get our answer. So after putting my matrix in a matrix calculator, I get 1 0 0 0 1 0 0 0 1, or I could just write this as I1, I2, and I3, and I'm getting minus 0.676 and 0.469 and minus 0.126, and these are all amps in amps. So you'll notice that this technique is very similar to nodal analysis, except you're just using Ohm's law and you're using KVL instead. And there's actually a reason to why this technique works so well, and I can explain that in a different video. It works the same as the traditional method. And that's pretty much it for this video. So I hope you enjoyed.